In this problem, we have a weak acid, HCOOH. Now we know it's weak because it's not one of the 6 strong acids. We are given a Ka of 1.8 times 10 to the minus 4. Okay, so that's our first number. And we want to calculate the pH of this particular concentration of solution. Okay? This first step you want to do in this process is write out the equilibrium, and this is going to be the top of the ice table, so you want to kind of spread things out a little bit. So HCO2H is the acid form, okay? And draw your nice equilibrium arrows here, and then write H plus, right? Acids produce H plus. And then write out the conjugate base. Remember, it's always going to have one less hydrogen. Doesn't matter which one you pull off, really, and then put a negative charge there, and that's aqueous. Okay. Step 2 here is that you want to set up your ice table. Now, I stands for initial, okay, the initial concentration. C stands for change, and E stands for equilibrium. Okay. So what we want to do is, kind of grid this up a little bit. Okay, so kind of make a table with some boxes. And we want to fill in all of the boxes here, okay? So the first thing we want to do here is consider the 0.060 molar solution. So all of the concentrations go in these boxes, and that's the only concentration. And that's right here. And that's it. That's the only number we have in this word problem. But you need to think conceptually about what is happening. Remember that when you initially start with a particular weak acid, you have no H plus and no conjugate base in the solution initially, okay? But then when formic acid hits the water, there's a reaction that occurs. This goes away a little bit, this forms a little bit, and this forms a little bit, okay? At equilibrium, we're going to have 0.060 minus that little bit. We're going to have 0 plus that little bit. We're going to have 0 plus that little bit. We can go ahead and simplify these and just write x. Okay, it has a value of x. Okay? So that's where we are for the ice table. That's step 2. It's very important to know what reaction you're talking about, what concentration you have, and fill in the info, okay? The third thing you want to do is write out an equilibrium expression. So KEQ, or capital K, is called equilibrium, and this is a capital K, all right? So it's always going to be products over reactants. Products are H plus and HCO2 minus. Okay, so those are the products, and it's going to be products over reactants. The only reactant we have here is HCO2H. Okay, and these are all, this is an equilibrium reaction, this is the equilibrium concentration, this is the equilibrium concentration, this is the equilibrium concentration. So we use the equilibrium values to plug in. Okay, this is the equilibrium constant. Okay, so 1.8. So step 4 is, kind of just plug and chug and solve, right? So 1.8 times 10 to the minus 4 is going to be equal to x times x over 0.060 minus x. And we do a really nice simplification. We assume that x is small. For weak acids, the percent ionization is extremely small, so we pretend like x is small, so we can assume the 0.060 minus the itty-bitty tiny number is about the same, 0.060, and this simplifies the math dramatically. What we end up with is 1.8 times 10 to the minus 4. That's going to be x squared. I'll just go ahead and multiply x by x here, and that's going to be divided by 0.060. we multiply both sides by 0.06 and then take the square root. So that gives us, after all of our mathematics here, 1.8 e minus 4 times 0.06 equals, don't forget to hit the square root button there on your calculator, and I get 0.003286, you know, something like that, okay? Now, what is x? X, remember, once again, is just a value that represents the concentration of H+, okay? So this is H+, okay? So that's important to not lose sight of the chemistry part of the chemistry problem. And so now we can calculate minus log of H+. This is how we calculate pH. So we're going to have minus log of 0.003286. And at the grand final here, we get 2.48. Okay, pH is 2.48. The last step in your analysis is to kind of grade your own work. Remember, we're dealing with an acid, so the pH should be less than 7, and we got a pH of about 2.5, so that checks out. It's acidic. All right. This slide right here that you can see summarizes the 5 steps you need to do to solve the pH of a weak acid, given concentration, given Ka. All right. Those 2 items will always be given to you. All right.